Hello and welcome everyone. In this video I will explain cost minimization problem of a competitive firm. Suppose a competitive firm hires L units of labor and K units of capital. The firm pays these factors the rewards in the form of wages W and rental R respectively. The firm uses production technology such that output is function of labor and capital, and consequently the firm cost would be total cost. A firm hires L units of labor and pays them W per unit. The total wage bill would be W times L, and the rental bill would be R times K. Remember that in the long run all the inputs are variable. We do not have fixed inputs, therefore we have all the costs as variable costs. If I'm interested in drawing the cost constraint the firm faces, we can do so by taking the horizontal and the vertical intercepts. So let us put L equals to 0 to get the specific value of K, denoted by K star, as total cost over R. This is the vertical intercept. If we set K equals to 0, then we get the horizontal intercept L star, which is equal to total cost over the wage. We specify these 2 points on the graph with labor on horizontal axis and capital on the vertical axis, and then can join the 2 points by a straight line. This is our isocost line. We can find slope of this line as W over R. Now we move to discuss the isoquants. Isoquants are called the level curves, and the reason they are called level curves is that consider the production function in 3-dimensional space where we measure labor on one axis, capital on the other axis, and output on the third axis. If we consider a particular production technology, then the production function in the 3 dimensions would look like something similar to Opera House. Suppose we consider some specific pair of labor and capital. At this pair, we see what is the height on the surface, and we pick one point. Likewise, if we take another pair, we can have another point on the curve, and so on. If we join all these points together, we will get a level curve here. Similarly, if we pick different pairs, we can get different level curves, and so on. Each level curve gives the same height. For example, this lower level curve gives us height y1, which is the output y1. The second level curves gives us height y2, and the third gives us the height y3. We can see that these level curves have fixed quantities of output regardless of what combination we are using. Like if we use this point or this combination, let's say L1 K1 or L0 K2, we get the same output, which is Y1. Therefore these maps are called the level curves. Let us think about these level curves in just 2 dimensions. That means we omit the third dimension output. We have labor and capital only in 2-dimensional space. And if we draw that level curve, we observe something like this curve here has an image on the 2-dimensional space or LK plane. If we draw all those curves, the images of all those level curves on the LK plane, what we observe is level curves one on the top of each other. And when we have several isoquants in one graph, this is called as Isoquant Map, where a lower isoquant gives a lower level of output and a higher isoquant gives a higher level of output. What we observe from this isoquant that gives us output y1, we can have different pairs of labor and capital that can be utilized to produce the same output level y1, and so on. The slope of the isoquant is known as marginal rate of technical substitution. It is the negative of the change in capital over change in labor units. We can rewrite this marginal rate of technical substitution as delta K over delta Y upon delta L upon delta Y. And then we can see that the numerator is in fact 1 over the marginal product of capital, and the denominator part is 1 over the marginal product of labor. And therefore, if we invert this, we can easily write the marginal rate of technical substitution as the ratio of the marginal product of labor to marginal product of capital. From the isoquant, we can see that as we increase the units of labor, we have to decrease the units of capital. And the change in capital over change in labor represents the marginal rate of technical substitution. But the question is the marginal rate of technical substitution when the labor is L1 and L2 and capital is K1 to K2 the same as when we move from L3 to L4 and decrease capital from K3 to K4? There is diminishing marginal rate of technical substitution, which means that if we want to increase one input, we have to decrease the other input, but the rate of change in the second input would be lower than the rate of change in the first input. So the slope of the curve at different points is not the same, and this can be seen by drawing the tangent lines at different points. For example, the tangent line at this point is quite steeper compared to a tangent line at point B. Let us discuss the firm's cost minimization problem. In this graph, we have labor on horizontal axis and capital on vertical axis, and this downward sloping line represents the firm's isocost line. We have seen that from the Isoquant map, the higher isoquant represents higher level of output, and it is firm's objective to maximize her output given the cost constraint. So we try to figure out how firm achieves its objective of output maximization given her cost constraint. Suppose the firm wants to achieve the higher level of output represented by this isoquant curve. This curve is beyond the firm's sources. It requires more of labor and capital inputs to achieve this level of output. Therefore, the firm won't be able to produce the output level corresponding to this isoquant curve. If we consider this isoquant curve, which intersects the isocost line at 2 points, again this is not feasible for the firm to produce, and in a while we will discuss why it is not the case. On the other hand, so there could be an isoquant such that the output can be produced given the firm minimizes her costs. Moving in this way, we see that of different isoquant curves, there is one isoquant where the isocost line is tangent to that isoquant curve, and that ensures that firm has achieved this maximum possible output given her cost constraint. Thus, we would have equilibrium established at the tangency point of the isocost and the isoquant curves. The number of units of labor hired by the firm would be L1 star with K1 star of capital, and the equilibrium point denoted by E1 star. If we think about the points of intersection of the lower isoquant curve and the isocost lines like point A and point B, we see that these would not be the feasible points of production, and the reason is there could be some other lower cost than the one in the given constraint, which can be faced in order to produce the same level of output which point A and B ensure. If we draw another isocost line which is parallel but to the left hand side of the original isocost line, we can see that the tangency requirement fulfills at point E0, and the firm can hire L0 and K0 lower level of quantities in order to produce the same output level Y0, which would be the same output if the firm produces either at point A or point B, but with a higher cost. Hence, we find from this analysis that a firm's cost minimization problem requires that firm should produce at a point where its isocost line is tangent to the isoquant curve as shown in the graph by point E1. From the analysis, we find that the equilibrium condition for firm's cost minimization problem is slope of the isoquant is equal to slope of the isocost line. We know that slope of the isoquant is marginal rate of technical substitution for the given output Q equals to Y bar, and slope of the isoquant is W over R. But we have also found that marginal rate of technical substitution is marginal product of labor over marginal product of capital. Thus, we can write the equilibrium condition as marginal product of labor over marginal product of capital equals to W upon the rental rate R. And if we reorganize this equation, then we can find that marginal product of labor over wage rate is equal to marginal product of capital over the rental rate. The left-hand side of this equation, marginal product of labor over wage, represents that an additional output that would result from spending an additional dollar of labor. Likewise, the right-hand side of the equation represents an additional output after spending an extra dollar for capital. Thus, we can interpret this equation as a condition that ensures that a cost minimizing firm should choose the number of units of labor and capital such that the last dollar spent on any input produces the same output as the other input. This completes my analysis of a competitive firm's cost minimization problem. Thank you very much.